We have two rational expressions here, and we're going to be finding the vertical asymptotes and if there's any holes in the graph. So the first thing we need to do is convert the numerator and denominator into factored form. So the numerator of the first rational expression can be factored by GCF, greatest common factor. So they both share a 5, and what's left would be x plus 2. The denominator can be factored by trinomials. So you're saying what multiplies to 10 and adds to 7, and that would be 5 and 2. Now that it's factored, we're going to check to see if there's any factor in the numerator and the denominator that match. And there is. The x plus 2's match. And so if I divide those, I just get 1. So what's left? I have 5 over x plus 5. So my vertical asymptotes, what I have to do is set the denominator equal to 0 because we cannot divide by 0. And that would give me my vertical asymptote. So if I subtract 5 from both sides, I get x is equal to negative 5. So to find the hole or holes, if there is any, you're going to look at the factor that got crossed out and you're going to set that equal to 0. So when I subtract 2 from both sides, I get x is equal to negative 2. So when we write our hole, we do write it as an ordered pair. So how do I find the y-coordinate? I look at the simplified form and I plug in negative 2 for x. So I would have 5 over negative 2 plus 5, which is equal to 5 over 3, and I could write that as 1 2/3. Or you could leave it as 5/3 if you wanted to leave it as 5/3. All right, taking a look at my second rational expression, I'm going to be rewriting the numerator and denominator in factored form. So the numerator can be factored by difference of squares. So I open up double parentheses, alternate the signs, one's a plus, one's a minus. X squared splits as x and x, and 49 splits as 7 and 7. My denominator can be factored by GCF, greatest common factor. They both share an x, and what's left would be x squared minus 49. Now I look at my denominator and I notice that it matches the numerator, which means it could still be factored. That is the difference of squares. So I'm going to erase the x squared minus 49, and I'm going to convert that to the factored form. So again, we're factoring this. I know I erased it, but we have x squared minus 49. So I open up double parentheses, alternate the signs. One's a plus, one's a minus. X squared splits as x and x, and 49 splits as 7 and 7. So now I take a look to see if there's any matching factors in the numerator and denominator. I could cross out the x plus 7's because they divide as 1, and I could cross out the x minus 7's because they divide as 1. So what's left in the numerator is just a 1, and what's left in the denominator is an x. To find the vertical asymptote, I set the denominator equal to 0 because you cannot divide by 0. So my vertical asymptote is 0. Taking a look for, looking for the holes. So I set each of the crossed out factors to 0. So x plus 7 is equal to 0, and then I have x minus 7 is equal to 0. So I will have two different holes here. So I subtract 7 from both sides, and I get x is equal to negative 7. And I know I have to write that as an ordered pair. So I'm going to record that right here. Negative 7. How do I find the y-coordinate? I look at my simplified form and I plug in negative 7 for x. So that's just 1 over negative 7, which is negative 1/7. When I add 7 to both sides, I get x is equal to 7. So that is the x-coordinate of my second hole. So to write it as an ordered pair, I need to take 7 again and plug it in for x into the simplified form. So that's just 1 over 7.